Once again, my name is Gerald Schroeder. I worked to show the confluence between science and Bible. I've been doing this. My background in the sciences, thank God, is strong from MIT, bachelor's, master's, PhD, all earned at MIT. A few years on the physics staff after then moving to Israel, where I've been for the last 40 years, and I teach now at the College of Jewish Studies in Jerusalem. At this idea of saying it's not conflict, it's confluence. Now, in the video that we just saw, that 5-minute video, 5 or 6-minute video, that talks about this discovery by science of how our universe came into being. I'm not discussing whether there are other universes at the moment. That's aside. Our universe had a beginning, and the beginning is very strong. The slide that you had, of course, you have this picture based on, and remember, this is from NASA, National Aeronautics Space Authority. It has every word on this is straight from their web, and we discussed by the fact that we could create the universe. Ed Hiron's work in 1973, published in the journal Nature, which is one of the leading peer-reviewed journals in the world, that you have the laws of nature. Here it's called the quantum fluctuations, also relativity, that allow the creation of the universe from nothing, provided, as we discussed, you have the laws of nature predating the universe. And what we derived from that, of course, was that we now have a discussion by science of a creation of the universe from absolute nothing by a set of forces, or a force that predates our understanding of time, that is not physical, but it works on the physical, like gravity. If I drop something, it falls down. A non-physical force predates our understanding of time, so it's not bounded by time, creates the universe from absolute nothing. It's the biblical definition of God. And as we talked about this idea of science saying, if you want to call that God, call it God. But, and now here comes the caveat, and this is by major atheists, the names of whom you've known, with whom I've spoken. If you want to call that God, call it God. We call it the laws of nature, but you call it God. But if it is God, it is a deist God. That is a God that sets up the universe in motion, injects the laws of nature into the universe, and then goes out and has lunch while the universe runs itself. A more dramatic picture that has happened, is present here, is from National Geographic. And this is really quite a dramatic, quite a more graphic picture than the one that we've shown, but it doesn't have the NASA symbol behind it. But it's this burst of energy, pure energy. The Big Bang produced energy, super powerful light beams, whether you want to call it string theory or whatever. It becomes electromagnetic radiation, the same stuff shining from your light bulb now, or shining from the screen that you're watching to your eyes. Electromagnetic radiation, super powerful light beams that then, via the brilliant insight of Albert Einstein, discovers that the energy can change form. Remember, the energy does not disappear. It can change form. E equals mc squared. Energy equals mass times the speed of light squared. Now that c squared, speed of light squared, is a gigantic number, which tells you that even in a tiny bit of m, mass, there's a huge amount of E, energy, because E, how much energy? Well, it's E equals what? mc squared. But it's not telling you that the energy disappears and becomes matter. That is what it's not saying. It says energy can change form and take on the form of matter. A parallel example that I use just for myself, and it's a good exercise for everyone. When you drink water, well, it's H2O, hydrogen and oxygen, H2O. When you drink water, you are literally drinking water in the form of, you're literally drinking water, yes, you're literally drinking hydrogen and oxygen in the form we call water. You just don't think of it as that, but it's a good example. It's a good way to keep in your mind, because at the same time, when you look in the mirror in the morning, and for some of us it gets pretty depressing, but you look in the mirror in the morning, you are literally, not poetically and not figuratively, You are literally looking at the light of creation in a form called you. Because that's what happened. The energy changed form, condensed, remained energy, but condensed became condensed energy. It's called matter. Over time, the universe developed, and in that development, we end up having a world that is amenable and friendly to us, at least in one platform, the platform we call the Earth. So the first point to get from that video, that 5 or 6 minute discussion of the creation of the universe, is that there was a creation. You realize that less than 50 years ago, the overwhelming opinion of the universe was that the universe was eternal. In fact, that's the origin of, or led to the origin of the term the Big Bang. Now, the Big Bang doesn't say what made the Big Bang go bang. It is merely a secular way of saying creation. And it was coined by a person named Professor Fred Hoyle, who was very active in cosmology, and he was being interviewed on the British Broadcasting Corporation, the BBC, on radio in the early 1950s, about 51, 52. And the editor knew, the interviewer knew, that Professor Hoyle felt that the universe was eternal, because most scientists felt the universe was eternal. I mean, the Greeks got it right. There's an eternal universe. Look at the stars. They don't change. Even Einstein made that. He said it was the biggest blunder of his professional life, where he could have predicted the creation of the universe, the beginning of the universe, from pure mathematics. And he changed his equation. One of the most brilliant minds ever changed his equation, put in a cosmological constant to balance an expansion factor which showed in his equations, and it was a fudge factor. And he wrote to his other colleague, Max Born, another Nobel laureate, said it was the biggest blunder of my professional life. I could have predicted the universe creation from it showed a dynamic universe, but the cosmological constant, like plus 1 minus 1 equals 0, that's essentially what he did. And so we have, but realize that we now understand there's a creation. But in Fred Hoyle's time, 1950, 51, it was considered to be, there were hints that there was a creation, but they're split from the surveys I've seen, and there are surveys available on the web, of asking scientists what their age, they think the age of the universe is. 2/3 would say age? What age? The universe is eternal. Hoyle was in that 2/3 majority. So the interviewer on the BBC program says, well, Professor Hoyle, what do you think about your colleagues that say that there was a beginning? And Hoyle responded, oh, they think there was a Big Bang. The term was coined in as a silly statement. There was a Big Bang. The press picked it up, and it became the way of talking about the creation of the universe. That's Fred Hoyle, who later we will see changes his opinion very, very dramatically towards there being a God active in this world. So we're trying to understand in these few minutes to expand on that video to see how the flow goes. We have a universe that is essentially tuned for life. It is so perfect that the secular, highly secular journal, most widely read science journal in the world, Scientific American, tells us how we can know that there are infinite Earths in parallel universes really exist. Well, you read the journal on the cover, you go out and buy a copy. Why not? Infinite Earths in parallel universes really exist. Now, what is their evidence in the article? But they give it to you in graphics, so you shouldn't miss it also. So I'll read directly from their text. Cosmologists infer, notice the backpedaling, really exists. Now they infer. Cosmologists infer the presence of these level 2 parallel universes, these other universes with different laws of nature. Okay? Infer the presence of these parallel universes by scrutinizing the properties of our universe. And they even map different aspects of the laws of nature. They even map them, and they say these properties, and then they list them. The 4 dimensions, one's time dimension, 3 space dimensions, gravity forces, they list them here. And then they say these properties, including these laws of nature, were established by random processes during the birth of our universe. Yet they have exactly the values that sustain life. That suggests the existence of other universes with other values that don't sustain life. If you talk about convoluted reasoning, I mean, I imagine the editor was fired after. I can't imagine they would let that go through. It's embarrassing as a scientist. The fact that our universe is perfect for life implies that there are other universes? It implies nothing of the sort. Our universe is perfect for life because it's perfect for life. And the only way that you can get around it, well, I think what his name was, the cosmologist Barr in London said, if you don't want God, you better have multiple universes. Our universe is too good to be true. It's just perfect for this. And there's point after point that tells us this. But the very fact that the Creator created a universe which has the ability to allow life to develop would imply very clearly that the Creator of this universe is interested in the universe. And that changes the Creator, whether it's from the laws of nature to a Creator that is interested in the universe. It changes this science God from a deist God to a God that is active in the world itself. And there are many clues that are there. One is the design. I will use Fred Hoyle as an example. Now Hoyle, as you said, starts off saying it's a universe that's eternal, and then as he studies more and more, he develops the understanding, this amazing basis of how the elements are formed. He realizes, and science realizes, that in the Big Bang creation, there's only a very short time when the energies are high enough to condense, because remember, E equals mc squared, you need a huge amount of energy even to get a small piece of matter to form, that all the universe is going to make in the immediate moments following the Big Bang are hydrogen, that's element number 1, and helium, element number 2, and a squidgen bit of lithium, number 3. The first 3 elements, the lightest elements. But the universe is pretty much about 75 or 78% hydrogen, about 25 or so percent helium. There's a few tenths of a percent of other items. Hoyle realized that the only way that we have heavier elements for life, like oxygen and carbon and nitrogen and iron and uranium, the heavier elements, potassium, phosphate, calcium, the stuff we need for life, is when stars, which make their energy by fusing hydrogen into helium, when those stars run out of hydrogen, suddenly they don't have a force, because that energy being produced in the core of the star is pushing out and the gravity is pushing in. So if the star is above a certain size and it uses up all of its hydrogen, so suddenly there's no more energy being made. So that force pushing out, which had balanced the gravity pushing in, is gone. What happens? The gravity takes over, boom, implodes, explodes, and in that explosion, Hoyle realized a brilliant insight. We take it for granted now. Everyone who works in the sciences knows it. For laypersons, they may be hearing this for the first time. They may be hearing this as something new, but every scientist realizes there would be no life in the universe if a star didn't explode and make in the forces then the heavier elements that we have. And in this part of the universe we call the solar system, there's so much of us in the region. What does that mean? So much of these elements that are required for life, the carbon, the oxygen, the nitrogen, the calcium, that it's clear that we are the result of one or two previous supernova exploding stars that produce the elements, and they draw together. The gravity draws them together, the common gravity, and most ends up of that stardust, because we're literally 5 billion years ago, eons ago, and there's other times and other information available about these big numbers, so we're not going to get worried about the numbers at the moment. Most gets drawn of this stardust, because we were stardust, into the sun, our star, but enough remains around it so that we can have these planets, 9 planets. I count Pluto as a planet, and one of those planets is just right in the right location, bingo, where the Earth is. Liquid water, perfect gravity for the right atmosphere. All these things that lead towards an indication that maybe God is actually interested in the world. But the nuance that Fred Hoyle, which changed him entirely, discovered in the making of the elements. Because remember, the Big Bang, they think there's a Big Bang. Hoyle is a calculation of the concentration of the elements in the universe, as more was known, discovers, not he but others in working this, in the distribution of elements in the universe, that carbon, which makes up half of our, if you take the liquid out of our body, half of the body weight of most life is carbon. That these trees, the half their dry weight is carbon. They get it from carbon dioxide in the atmosphere, which is amazing in itself, and that's a whole other talk. But the wonder's all around us. Carbon, it's the sixth element. Hydrogen, going up is weight. Hydrogen, the lightest. Helium, 2. Lithium, beryllium, boron, carbon. Carbon's number 6. That carbon is the most abundant element in the universe that's solid in the temperature range that water is liquid. The significance of that is that carbon can form these amazing, of course, if it was a gas, like oxygen, or if it was a gas, like nitrogen, the gases they may form 2 atoms together, but they, like N2, nitrogen to nitrogen, but you don't form major, large elements, carbon dioxide, but you don't see complex life except that the carbon molecule is the only molecule that can make what's called these benzene rings, the rings that make you able to live, to think, to move your fingers. It's all in there. Just to move your fingers, the billions of reactions, and they're all based on molecules that are carbon. And carbon turns out to be the most abundant element in the universe that is solid in the liquid range, that in the range that water is liquid. Obviously, hydrogen and oxygen, there are more. Hydrogen and helium, there are more. But we're talking about solid. Now, Hoyle, that essentially drove Hoyle over the top for trying to understand this. And he wrote, I quote him in, pardon me for mentioning God according to God, he wrote an essay about this phenomena. Because for that to have happened, for carbon to be the most abundant element in the universe, there had to be a nuance, because there's my background's in nuclear physics, so I'm not going to get into nuclear physics at the moment, but as you build the elements up, you're adding protons. What makes up the center of an atom is protons and neutrons, okay? Hydrogen has 1 proton, helium has 2 protons, carbon has 6. But to get to 6, there's no way to get to 6 through anything that's stable. You can add up to 6, but the precursors that lead to carbon, none of them are stable. They all decay immediately, like radioactive decay, but we're talking about in microseconds. So what has to happen, he realized, to get carbon to form, there had to be 2 heliums to come together. Now we want to get to number 6. Helium is number 2. So 2 heliums are 2 plus 2 for 4. See, physics is very simple. But then you had to get the 3rd helium. 2 plus 2 plus 2 equals 6. It's some arithmetic. To get to that, there had to be what we call a resonance that would essentially grab that 3rd helium, because the 2 together are not stable. The 4 is not stable. You have to get the 6th in there, and then it becomes stable. Hoyle discovered this, and he discusses what the implications are in the journal Engineering and Science from Caltech. My background's MIT, East Coast. West Coast is California Institute of Technology, Caltech, one of the 2 leading science universities in the world. And if you want to see God's interest in the world, here he says it right here. This is Fred Hoyle, professor, in a journal published by a totally 100% science universe, California Institute of Technology, Caltech. Would you not, how you could get this carbon, would you not say to yourself, some super calculating intellect must have designed the properties of the carbon atom? Of course you would. The chance of my finding such an atom through the blind forces of nature are utterly minuscule. Of course, a common sense interpretation of the facts suggests that a super intellect has monkeyed with the physics as well as the chemistry and the biology, that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me to be so overwhelming as to put this conclusion beyond question. That's Caltech speaking, because it went through the editors there. There's a super intellect, we just call that God. You know, sometimes it's hard to get the God word into the text, but it's obviously what he's talking about. And it changed his opinion also. He became an overwhelmingly active proponent of the fact that there's a design in this universe, that the designer, and that there's an interest in this world. Darwin saw it also. Darwin saw this also. Darwin gets a really bad rap. People say Darwin, evolution, right. But the problem is no one ever reads the Darwin's Origin of Species, 1859, to the last paragraph. Get to the last paragraph, and it's very, very interesting. And I quote it exactly. Again, pardon me for I don't have the Origin of Species with me, but I have. Why not? You know, I have. Here it is, right here. Here is Charles Darwin's closing lines of The Origin of Species. However, as published by the Smithsonian Institute, the museum, the Natural History Museum in New York, and by Stephen Jay Gould, one of the major best. In fact, Time magazine at the turn of this century said Gould was one of the 20 most important writers in the 20th century. Stephen Jay Gould, when he speaks, people listen to him. And why not? He should know the Bible. After all, he even says that his forefathers served in the temple. So he wasn't embarrassed about that. That means he was in the priestly class. And here is how he quotes the closing lines of The Origin of Species. While there's a grandeur in this view of life, with its several planets gone cycling according to the fixed laws of gravity, from so simple a beginning, endless forms, most beautiful and most wonderful, have been and are being evolved. That's Gould on Darwin. That's the Natural History magazine of the Museum of Natural History in New York City, and it's also published once in I believe it's Scientific American. But here is Darwin on Darwin. I'm going to just quickly read the first few lines as usually presented. There's a grandeur in this view of life, or the planet has gone cycling, evolution. Here's Darwin on Darwin. There's a grandeur in this view of life, with its several powers having been originally breathed by the Creator, capital C, by the Creator into a few forms and into one, that the planet has gone cycling, endless forms evolve, most beautiful. Guess what's always left out? Consistently, there's an effort to present science in a secular way. What was left out consistently, with its several powers having been originally breathed by the Creator into a few forms of one. The simple fact is that there is this indication, that there's indications of God's active. I want to give just one example, also as being Jewish, of example of God's love for the people of Israel, also the very founding of the state. Leon Lederman, not the TV man, the Nobel laureate physicist. I was speaking with him in a hotel in Jerusalem, and we talked science. And then finally I said, well, Professor, and I went home and wrote it down. Professor Nobel laureate Lederman, what do you think about the spirituality? We've been talking about the physical. Spirituality, he said, leave that for the guys in the Jewish studies course. But then without a break, he said, but I do find something spooky about the people of Israel coming back to the land of Israel. You see, Leon Lederman found nothing spooky about the Eskimos eating fish in Alaska. Nothing spooky about the Italians eating pizza in Rome. But he found something real spooky, that you see people walking up Jaffa Road eating inside a pizza falafel balls, because it doesn't make sense. Now, for those that don't falafel, I urge you, come, I'll treat you to a pizza of bread that opens like this with falafel balls in it. That he found spooky. He doesn't mean spooky, it means godlike. It doesn't make sense statistically. One last piece of information here, and it's from It is from another extraordinary person who calls himself an agnostic. Letterman isn't going around, hallelujah, there's a God. Now I don't know what he feels, but in those days, I think he felt there was a force in the world, but, depends on what level. In any event, the Robert Jastrow calls himself an agnostic. He became at NASA. He was one of the founders at the beginning of NASA, and also became the director of NASA's Goddard Institute for Space Studies. Robert Jastrow. In the beginning, there was a bang, and it was a big one. It's an article that he writes for the Los Angeles Times, but he closes the article with a quote that is known around the scientific community and around the secular community. He's talking about what science has discovered, what we've been talking about here, an earth tuned for life, life that's so complex. We talk about it in other sessions, that your vision changes the picture 10 times or more a second. So it allows you to look and run, motions of your hand, that billions of molecules, billions literally, are moving here from the information up here in the brain down here to get my finger move. It's so complex that I think Disney wouldn't even make a movie of it, because no one would believe it possibly. It's science fiction. But it's not science fiction, it's you. Here's what Jastrow says. The closing lines of this article, there was that appeared. In the beginning was a bang, a big one. And this is from the 1970s, so it was when the Big Bang was just being established. Because realize, science held the universe was eternal, most scientists, until less than 50 years ago. For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. God is active in this world, and science shows it, and even in sociology, I just bring one point here from an article in the journal Nature, one of the two leading peer-reviewed journals. Why were Scud casualties so low? They did a statistical study. Everyone doesn't even have to say why they were so low in Israel, because we're talking about the war when Iraq, for some crazy reason, started shooting missiles at us. 39 missiles landed in the most heavily populated part of Israel alone. There was only one direct kill. Well, that number, God forbid, is terrible. One person gets killed, but it should have been, God forbid, much higher. The journal Nature did a statistical study. Now, to get 2 pages devoted to a study in Nature, it's got to be good. Point after point, they say the only reason that the Scud missiles were so low was, it's a 4-letter word, luck. Luck. They talk again, luck. Landed right in the only field between a quadrangle of buildings. The buildings were shattered, but most of the force was in the field. Luck. Evidence suggests that luck helped. Luck was, again, luck. It's almost a joke. It's almost like the Scientific American article saying there must be other universes because our universe is perfect. If you want to see God active in the world, we're greeted, as the scientist pulls himself over the final rock, he's greeted by a band of theologians who have been sitting there for centuries. A statement by a person who calls himself an agnostic. He's really not sure that there's a God in this world. Well, God's not going to come out and ring the bell. God is in the gentle voice, right? When has to flee. When the prophet has to flee, and when Elijah has to flee from the mountain. Thank you. Someone in the audience just told me it's Elijah. When Elijah has to flee, and God presents himself not in the thunder, not in the lightning, but a still small voice. God knocks very gently. You have to listen to hear. But if you listen, you will hear. The theologians got it right. About 5 minutes over.